So today we're going to look at what happens when you reflect an object, this triangle, about three parallel lines of reflection. We're going to see how it works when you reflect about the first line, then the second and the third, and what results from that. Then we're going to look at what happens when you reflect about the second, the third, and the first. And lastly, the third, the first, and the second. Now, um, basically, what a reflection is just a mirror image of this object on the other side of a line of reflection. So that's what we're going to show you today. What occurs when we reflect about three lines. So first off, the program we're using right now is GeoGebra. It's easier to use than pen and paper to show you exactly what's going to occur when you reflect about three parallel lines. So we'll take this object, reflect it about this first line. As you can see, the orientation G to H to K changed from being clockwise to counterclockwise, G to H to K. So we'll take the second figure around this second line, line M, I'm going to call it, and this is line N, and this is line L. And then we're going to take this last reflection about this line. Now, as you can see, this reflection, this object has reflected to this object. Primary cases that you could see that G to H to K, G to H to K, orientation changed from clockwise to counterclockwise. But you can also see here that it is just a strict reflection about line M. This line right here, where this point on the left side of line M is one away on the left side of the object as it is on the right side. Point G is two away from the line of reflection on the left side and is two away on the right side. And the same with H. Two away on the left, two away from the right. Now you're asking, well, yes, I'm giving you only three different opportunities to see what these reflections are. But if you do the reflections in reverse, so right now I reflected about L, M, N, I'm going to show you that when I reflect about M, N, L, you're going to get this exact same object. So when you reflect about that third line, then you reflect about the second line, and you reflect about the last line, you get the same object. It's just a mirror image of itself. So as you can see, this object has reflected about x equals 2. From my knowledge, from what I've seen in doing this project, I've seen that the way that you can get the line of reflection is to take the distance away from the origin that each one of these lines of reflection are. So this is distance 1 away, distance 2 away, distance 3 away. When you do the distance 1 minus the distance 2 plus the distance 3, you get 2, which is your line of reflection. This will work. This seems to work in all cases, no matter how far the lines are. So the next one we're going to look at, it's the same object with the same three lines of reflection, just a different view of it, is reflecting about the second line, M, second line M first, then reflecting about the third line, and then reflecting about the first line. And as you can see, it is just a reflection again along the y-axis, or x equals 0. So so we did the second line, 2 minus 3 is negative 1 plus 1. Your line of reflection is now x equals 0. And as you can see, it is just a reflection because EFB here has become is clockwise here. EFB is counterclockwise on this side. The orientation has just changed. And then when looking at the last one, again, this is the same object with the same three lines. We're going to reflect about the third line first, First, I got to get my parallel tool, reflect about the third line, then we're going to reflect about the first line, and then we're going to reflect about the second line. And as you can see, again, it is just a reflection. EFA clockwise, EFA counterclockwise. Again, we're going to look at the distance. So we did line distance 3 first, minus 1 plus 2. The line of reflection is x equals 4. Now, just to show you that this works, I'm going to draw in a line here at x equals 4. And I'm going to reflect the initial object about x equals 4. And as you can see, it was placed right on top of the old object, or the new reflected object. It is just a reflection about one single line. Now you may ask why this happens. Well, because with the first reflection, you see that the orientation changes. When you do the second reflection, you see that the first reflection, it changes. The second reflection, it changed again, but it's in the same orientation as the initial object, but just basically a translation, in this case, to the left. And then you do a third reflection, which becomes the reflection about a fourth line right here. In the other two, we only saw it about an existent line, but it is possible that it will go about a line that is non-existent at the time. But it is just to show you that this is possible, where if you reflect 3 times about 3 parallel lines, that there exists a fourth line, whether it is here or not, that the object will just have one reflection if you just handled it that way.